All right, well, let's ease into it. We'll get started. I'm Josh Mandel. I'm the chief architect at Microsoft Healthcare, and also the architect for the Smart Health IT project, which is what I'm going to be telling you about this morning. As we get started, I just want to point out there's a link at the top of the deck here. This will be displayed on the first few slides, which is just a link to the content that I'm presenting here. So if folks want to follow along, it's bit.ly/smart-FHIR-tech. And that's not a link directly to this deck. It's actually a link to a very short document with about a half a dozen slide decks that deal with smart and clinical decision support hooks and a related set of technologies. So it's one level of indirection, but it gives you resources for all the presentations that I'm going to be doing here at DevDays and some of the ones that we've done at affiliated conferences and meetings as well. So with that, I want to dig in and tell you a little bit about the problem that's motivating the Smart Health IT project. I should say ahead of time, I would love for this to be an interactive session. So by default, I will just march ahead and talk at you all for about 35 minutes or so and try to save some time for questions at the end. But if you've got questions that come up midstream, particularly if I say something that's confusing or surprising, or if you're just interested to know more, please do raise your hand or shout out. I would love to answer your questions here and now. That's one of the advantages of all being gathered in one place that people who are watching the videos afterwards won't have directly. So strongly encourage you to speak up, participate. Let me give you a sense of some of the motivation here. So we're talking about apps that can plug into health record systems. Many different use cases for these kinds of apps, but generally thinking about external tools that are developed by one company and can plug in and work with services, health record products, patient portals that were developed by another company. And the truth is that even though there's a lot of technology that touches on this area, it's still very early days. So we commissioned a report from class a couple years ago, getting the healthcare provider perspective on where they see the state of apps that integrate with their health record technologies of the day. So the content of the report is available at the Smart Health IT website. But I wanted to just share one example of a quote, something that we heard from a provider who participated in this report. And here's the quote. It says, "We had this wonderful population health tool, but we couldn't get the EHR system to interface with it. And so we had to enter information by hand, and eventually we just gave up because we couldn't keep up with that kind of hand data entry." And this really captures a lot. It says we're at a stage right now where there's sort of a frothy development of many different tools that are valuable, but a tool in isolation is less and less valuable because we're expected to be using so many different apps and tools and services. If they don't integrate well, and the burden winds up falling on individual clinicians or end users to try to bridge those gaps, these tools just will not survive on their own. And that's really the best way to sort of encapsulate the problem statement here. So let me give you a sense of the work that we've done on the SMART project going back really to 2010. This was the first project that I worked on fresh out of medical school. I had become really interested in this problem of, from a developer's perspective, what are the interfaces that we need? And this is something that's evolved over the course of nearly the last decade. But this is the core focus. On the one hand, we've got a number of different healthcare applications that could be built by third-party developers across the ecosystem. And on the other side of the screen, we've got many different clinical systems. So one of the key use cases for us is certified electronic health record systems in the context of the United States. And there's a very long tail of these systems. There's hundreds of systems that have met certification criteria from sort of one of the versions of this national program. And the question is, how can you allow healthcare apps to integrate into these different kinds of systems? Whether it's a clinician-facing EHR, whether it's a data warehouse, whether it's a patient portal, but don't make the app developers learn 1,000 different systems, 1,000 different APIs. Even if the APIs are openly published and not secret, still just the work of independently integrating with every one of these things is overwhelming and frankly impossible when you get to a certain level. So our goal is to say, what are the sets of tools and patterns and standards that we can use to enable this kind of plug-in architecture? And we're going to focus on a few things in today's session. First of all, we'll talk about user experience integration. This is particularly important from the clinician-facing aspect, where I've got an electronic health record system that I'm using day in and day out. If I want to run an app that connects to my EHR, well, I don't want to launch it outside of my EHR and then go and reselect the patient in order to establish that context every time I see somebody. I want the user interface of the app to be integrated into my clinical workflow in some consistent way. The next two are really about security. So authorization, how do you give apps access to the data that they need without giving them overbroad access or access to data that they shouldn't need to get their job done? And the other security topic is single sign-on. So especially if I'm a clinician running many apps over the course of my day, I don't want to have to create a new user account and manage different credentials for every app that I'm using in that workflow. There has to be some reasonable story about single sign-on, allowing those apps to learn about my identity without requiring me to juggle a new set of credentials. And of course, clinical data. And for the purposes of our conversation today, I'll pretty much just say, we're using FHIR and a set of FHIR profiles. We can delve into the details if there's interest, but there's a set of US core profiles that have really developed from this work. And as far as we'll be concerned, we're just using those profiles when we want to access clinical data. So that's the basic focus. And I want to say a little bit about the value proposition here, a little bit for end users. So if I'm a patient or if I'm a clinician, the value proposition is I get to choose the apps that I want. And so SMART is actually an acronym. It stands for Substitutable Medical Applications and Reusable Technologies. And that first word there, substitutable, is really the key. The idea is if a user has a particular schedule management tool or a particular medication manager that they like, they should be able to use that one. And if a better one comes out next year, they should be able to switch. And they shouldn't have all their old data sort of locked up in the old tool. The data should be available at a platform level. Now, from the software developer's perspective, this really becomes a question about lowering the barriers to entry. So in particular, I can now build an app that can plug into a diverse set of systems. I don't need to have a custom integration team that's focused on integrating with every different electronic health record that I want to work against. So I can build an app once and run it across a diversity of systems. Now, I always like to pause here and say, this vision of write once, run everywhere is a great vision. It's absolutely an overpromise. So I'm not going to try to sell you on the idea that this smart API is going to let you write your app once and connect it to thousands of EHRs. It's just not the reality. But what it does is very significantly chip away at this integration burden. So we'll talk about where this API is deployed in production today, and we'll look at examples of apps that, with very small tweaks, can run inside of a diverse set of clinical systems. I don't want to oversell it, but it is very powerful. And of course, there are some apps that are relevant not just for clinicians or for patients, but individual apps that have a diverse set of end users. So it's quite powerful to be able to build this app once and deploy it for different kinds of end users inside of this ecosystem. And this really bends the economics of building an app, because something that otherwise might be unaffordable is now something you can think about building at scale. And I'll give you an example of a research project at Boston Children's Hospital where we were interested in helping clinicians track pediatric patients' blood pressures better. And typically what would happen in an academic hospital is you would you'd work with the IT staff there, you'd build an app that was sort of just good enough to run locally. You'd make sure your internal clinicians and stakeholders were happy, and you'd release it and hopefully maintain it for a while, and then eventually it reaches the end of life and maybe something better comes along. But it wouldn't make sense to try to build a really polished user experience around that thing because you couldn't do anything else with it. But if you can now take this app and distribute it, whether it's open source or through a commercial model, and many children's hospitals across the country can now pick it up and use it, the economics of developing that app have fundamentally changed. So when we think about this, what that means is that the EHR becomes a kind of platform. It handles the core details that you wouldn't want every distinct app to have to cover. So things like user and patient management, workflow, and the orchestration of core services like electronic prescribing. All those become centralized platform issues. Data persistence, regulatory compliance, but then apps can mix and match the data as they see fit. They can provide additional user experiences and better, more tailored workflows. So that's the core value proposition here. I want to dig in and talk about the technology, and then we'll zoom out and talk a little bit more about the community and where these kinds of tools are being implemented. Normally, I would say a little bit about how we're using FHIR for clinical data, but at FHIR DevDays, this is something people understand pretty well, so I'll just say we're using FHIR. The other major standard that we use is OAuth 2, and we've got a set of implementation guides that allow health records to support OAuth 2 so that client apps can plug in. And when we talk about OAuth in the context of SMART, we generally talk about what we call app launch. And this is the idea that somebody wants to run an app. It's not running yet, but we're going to take them through the process of starting that app up and making the connection. And we've got two processes in SMART, two different ways that we can launch an app. I'll talk you through each of them. The first one is what we call a standalone launch. And the idea here is an end user starts from the app rather than starting from the EHR or the patient portal. So a good example here would be I run a health records app on my mobile phone, and I want to connect that app to an EHR. Well, that's a standalone launch because I started by launching the health records app, and then the connection to the EHR comes afterwards. And basically what this does is it sets up an OAuth flow. If folks are interested in learning a lot more details about OAuth and some of the extensibility points in OAuth, we're going to be doing a deep dive session on Wednesday, just around noontime. But for the purposes of today, the OAuth flow, we'll look at a simplified version. Effectively, the app does a redirect to the EHR endpoint to say, here's the connection that I want to establish. This passes along some basic details like its app ID and a list of scopes. In other words, what permissions the app wants. We'll talk about scopes in a minute. And then the EHR is responsible for performing some kind of user-facing authorization step. So particularly in the case of a patient-facing app, like the mobile example that I gave, an end user, that patient, would typically sign in to their patient portal using their own patient portal credentials. And I want to highlight the fact here that the patient is not sharing their portal password with the app. That's one of the main things that OAuth gives us, is that I can give specific permissions to an app without having to give away the keys to the castle. So I've got my portal account, I've got my password. I'm only going to ever type that password into my patient portal, not into my app. What happens is once I sign in, then my portal says, it looks like you're trying to give access to this particular consumer app on your phone. Do you want to share that access? And you can click yes or no. And then depending on what you decide, you're sent back to the app. At that point, the app is able to get an access token, and then it can use that access token here in step 3 to fetch clinical data using FHIR. So that's what we call the standalone launch. It's particularly relevant for patient-facing apps, like Apple Health Records is a good example of an app that you can launch on your phone today using this workflow. And I mentioned that there's a user-facing step in the middle here. I should give that a slight caveat and say, usually there's a pop-up that asks a patient to hit approve, asks the patient if they really want to make that decision. But there are some cases where that step may be automated. One example would be if the patient has already signed in and already given approval to this app before, the EHR portal might remember that fact and might simply pass it through. So there's room for these things to be tuned with locally relevant kinds of policies. But as far as the app is concerned, it asks for access, the user signs in and makes a decision, and then based on that decision, the app gets an access token. That's the standalone launch. Now I'm going to switch over to the EHR launch, which is going to look very similar, but you'll see a little bit more detail here in step 1. So really what this does is it prepends a step. It adds one more step to the top here, where instead of starting from the app, we're starting one step earlier from inside of the EHR. So for example, I've got a patient record open, and I'm going to launch that blood pressure app that I mentioned. So in this case, the EHR already knows a lot of context. It knows which patient I have open. It knows who I am as a clinician. And when it goes to launch the app, it passes that context to the app in this very first step. And then all the other steps look exactly like we talked about already with the standalone launch. And the end result there is that the app can get access to, for example, a single patient record in the context of a clinical workflow without the user having to go in and select that patient, because that context flows through this set of steps. So those are the two main ways that we launch an app. Standalone if you're starting from the app like on a mobile device, and EHR-based if you're launching the app inside of the context of your existing workflow. These are both OAuth 2-based specifications that have been standardized through HL7. And there's links to the details of how those work if folks want to get a deeper sense of each of those steps. I want to say a little bit more about permissions in particular. I mentioned the idea that when the app launches, it asks for specific scopes or permissions from the EHR. And what we have in Smart today is a kind of a language of permissions, or what OAuth calls scopes, that allow apps to ask for the data that they want, and they can specify, here's the things that I need, so that an end user or the EHR system that's making these approval decisions can review what the app is asking for and grant access to just those things. This is important from the perspective of minimizing access to data to just what's relevant or just what's needed for a use case, and it gives particularly consumers more control over what they share. And the way that we break down these permissions is by FHIR resources. So basically, if we have an app that's going to do something like immunization viewers, so I'm going to show you a set of immunizations that you've received in the past. Well, this is an app that basically needs to access data about one patient, the patient that's currently in context. So that's what this first slot here means. When we say patient, that's the access type. Then we get into which FHIR resources we need to read. So in this case, the FHIR resource would be immunization. And then we get into the particular interactions. So here, the permission that we need is to read those immunizations. And by putting these three pieces together, an access type, a FHIR resource, and then the permission on it, we create what's called a scope. And an app can ask for as many scopes as it needs to get its job done. So for example, if I've got a simple app that's showing me historical vital signs, it might ask for the ability to read a patient's demographics, so that's patient.read, and to read observations, so that's observation.read. If I've got a complex app that's showing me many different aspects of my clinical history, or if I want to share all of my data with a personal health repository, I might want to grant a permission like patient star.read. And that says grant access to all resources that are associated with the patient in context. A couple more examples. Maybe I've got an electronic prescribing app, so that's something that needs access to write medication orders on a particular patient. Or maybe at the population health level, we'll look at one other access type, which is user-level access. So the examples I've shown you so far are all within the context of one patient record. But if I've got a clinician-facing app that's going to manage my schedule, for example, I might want that app to be able to query data from across all the patients that I, as a clinician, have access to. And so there the access type is user. And this would be a scope that says, give the app access to all the data that I, as the clinical user, am allowed to see. So that's user/star.read. That's the basic way that we do permissions in Smart today. I want to call out a couple of points here. So one is that this kind of resource permission is modestly expressive, but it's also pretty coarse-grained. So I gave the example of observations earlier, and if folks are paying close attention, you might think about the fact that FHIR observations can be used really broadly. So in FHIR, the observation resource is what's used for vital signs, but it's also what's used for social history, like maybe smoking status, but it's also what's used for lab results, which could be anything from a basic set of blood chemistry to really sensitive lab results like HIV. Like HIV status. So in this context here, if I've got an app that really just wants to show historical vital signs to show how a child's growth has progressed over time, I have to ask for observation.read, which is much broader than what I really want. So there's room here in the standard to do a better job of having more expressive scopes. We haven't got there yet, but there's very strong interest across the industry in trying to figure out whether there's something that we can do that would be both expressive and implementable in the real world. And I just want to point out that there's a pop-up session coming up this afternoon on this particular topic. I think it's at 3:50 p.m. So anybody who's interested in digging in more on scopes and some of the use cases around finer-grained permissions, that's a session that we'll be running. I want to talk now a little bit about the community and then dig into developer tools. So first of all, this Smart work that we started a while back, I mentioned all the way back in 2010, has been reviewed and vetted and indeed improved by going through a process with the Argonaut project. I won't dig into many details about the Argonaut project except to say this was a group of EHR vendors and clinical provider organizations that did a deep dive on the spec and then committed to supporting this specification in a consistent way. If you want to hear more, Mickey Tripathi, who runs the Argonaut project, is doing a keynote this afternoon. It's a great place to get some background on the Argonaut project and then hear about where things are going. A lot of exciting work happening today in that community. On the adoption front, this is just an example of one of the earliest adopters. Ricky Bloomfield was at the time running a group at Duke University that had looked at supporting Smart before there was commercial support available from many of the large health record vendors. And so they went off and they actually built a set of Smart on FHIR services inside of their own EHR ahead of what their vendor was able to provide out of the box. Now, fast forwarding a few years, this kind of support has become available pretty broadly from some of the major EHR vendors, and we'll be talking a little bit more about that. So ultimately, this is something that, from a provider perspective, it's really nice if you can get this out of the box from your EHR vendor, but there's always the opportunity to build this locally. And that's an important part of the way that this is designed, which is to say anybody can build the layers to support these kinds of specifications internally at the organizational level if you need it. So from the Smart Health IT perspective, one of our goals, beyond just providing the technology and the specifications, is to bring together community and help developers and other participants in this ecosystem understand what apps are available and share information about apps that have been built. And so to this end, one of the websites that we maintain is a Smart App Gallery. It's a place where any developer can list information about the apps that they've built. It's free. It's license neutral, vendor neutral. Anybody can come and just publish information about the FHIR apps that they've built, and anybody can come and browse a set of those apps. And I'll give you just a quick demo from the perspective of the app gallery. This lives at apps.smarthealthit.org, or I think apps.phir.org should also take you there, but apparently the HTTPS redirect isn't working right now. And there's, generally speaking, a view of apps that's categorized by different areas of interest. And I'll just show you sort of a quick example from the perspective of one of the open source apps that we've built, which is the Smart Growth Chart app. So this is an example of a listing. Every app has a title, some basic information about what the app does. It can include some screenshots or links to videos about the app, as well as information about FHIR compatibility. So which versions of FHIR does it work with? What kind of end users is this app designed for? It can include information about which EHRs it's known to run in. So for example, for this growth chart app, we've got links to the Cerner App Store and to the Epic App Orchard where this app can run. And so any developer can come and list the apps they've built. One of the neat features of the gallery is also this try it button. So the gallery also comes linked to a demonstration server with some sample data loaded in it. It's part of the smart infrastructure. And so I can click the try app button here. And what I'll get is sort of a simulated EHR environment. In this case, I'll get a list of patients to try it on. Since it's a pediatric growth chart app, the developer was able to select just a list of pediatric patients, so the patients that it would be most relevant for. And then if I pick a patient, then the app can launch against that patient record, fetch the historical vital signs, in this case, heights and weights, and then plot those against a growth curve. And I won't go into the details of the app here, because I just wanted to show you a demonstration of how the gallery allows this kind of listing. And so you can sign in with a Twitter account. You can create your own listings in this gallery. And certainly if you're building something, whether it's clinician-facing or patient-facing, I'd encourage you to take a look and at least create sort of a basic listing in this gallery. It's a great way for patients and clinicians to see what's out there in this space. So that was a quick demo of the gallery itself. I want to talk about a couple of related projects so you can start to get a sense for how the SMART team and the Smart on FHIR project is sort of linked in here. One is better access to population level data. So everything that we're talking about here in this session is really apps that connect and access data about one patient at a time. But there's been really strong national interest, and international interest for that matter, in apps that can connect and do an export on whole populations of patients all at once. And I'll just give you a forward pointer. Dan Gottlieb is here at DevDays and will be doing an overview of the FHIR bulk data specification. And that's a project that we started inside of the Smart Health IT organization and has, again, gone through this Argonaut project. So that's one forward pointer to a project that you can learn more about here at DevDays this week. Another forward pointer is clinical decision support hooks. And this is a project that's really designed on the clinician-facing side, although there are some patient-facing use cases as well. The goal is to be able to provide external information layered onto the workflow. So for example, as a clinician is navigating through the EHR or writing a prescription or doing specific activities, how do we layer on important information that can be displayed ambiently alongside that workflow? And that could be extra background information about a patient. It could be suggestions about which medications would be the most appropriate. And that's a project that's called Clinical Decision Support Hooks. One of the places where this becomes really interesting is as clinicians start working with more and more apps throughout the course of their day, it can be hard to know which apps are going to be the most relevant for which patients. And CDS Hooks provides a way for an external service to say, hey, here's an app that would be useful for you right now. So even if a clinician didn't think to launch this particular app, they can get a relevant and curated set of hints made available inside the context of that workflow. And Dennis Patterson from Cerner is going to be doing an overview of CDS Hooks here at DevDays this week. I'd encourage folks to check out that session for a related set of specifications that sort of builds on this Smart on FHIR set of capabilities. One more project that I want to just give a quick shout out to, since this is one that I'm still actively running at Harvard Medical School, is using this set of APIs to help patients share their own data with research studies. So this is a project called Sync for Science. And the goal is, rather than inventing a new set of APIs for research, let's use the ones that we've got. Let's use these Smart on FHIR scopes and permissions and work to make sure that as many vendor systems as possible can support this set of APIs. We've been doing some work with the All of Us research program, which is a big US-centered, NIH-funded research study to follow 1 million patients over 5 years or more and track many aspects of their health. EHR data is just one small piece of that overall tableau of data, but we've been looking at Sync for Science and using this technology as one way of bringing health record data into that program. So just trying to give you a sense of some of the places where this technology is being used. And now I want to dig in a little bit to some of the developer-facing functionality, give you a sense of how you can get started building an app right away. And dev.smarthealthit.org is really the best launching place if you want to see a list of tools and services that we provide for developers to get started. I'm not going to give you a demo of that site right now, but I'll show you a couple of the tools that are linked to from that site. I want to just give you a quick view on how some of this works. Let me do a quick time check. I think we're 25 minutes in, which means we've got 15 minutes left. before I start digging into some of the demos and developer tools, let me just pause and see if there are questions based on what you've heard so far. Yeah, please. So I think there's a comment here about sort of how interoperable this can be and challenges there. I think it's something we better take offline because it sounds like a detail-oriented question, but I'd love to dig into it because we do try to provide enough guidance that round trip should work out of the box. So let's follow up after the session. Let me see if there's one more question before we dive into developer tools right now. All right. Oh, yeah, please.
I have an application that I use. I brought in my own jar files to do an OAuth 2, and then go into a legacy database, extract the data, and convert that into FHIR format and give it to the users. Is there a place for Smart FHIR that I can change my application to use that?
So I think the question is, you're building something that, a system that contains clinical data. So it's more like a server than a client in this architecture. And there's a bunch of microservices that sort of make part of it. And you support OAuth in some ways today. The question is, how should you be thinking about Smart? And I think the way that I would describe it for you is to say, you could think about implementing the Smart API, which is to say the server side of what Smart defines. In general, out-of-the-box OAuth libraries are a good starting point. There's a couple of additional parameters that you'll need to support in order to be compatible with the Smart on FHIR specification. And we've got some documentation, and we've got a quick start guide for server developers that would probably be the right place to get started. So from the documentation perspective, docs.smarthealthit.org has a few tutorials, including a perspective on building a server. So this is probably the best place for you to get started when you think about layering this onto some existing services that you've built. We talk about an EHR here, but you can think of this as really any clinical data system that is hosting FHIR resources and wants to make them available to apps through this Smart on FHIR specification. With that, let me dig into a couple of the tools, because I think you'll start to get a sense of how these pieces come together. I want to show you a quick demo of what we call the Smart App Launcher. And this is a tool for developers who are working on an app and want to be able to test it out against a sandbox environment and be able to test out many aspects of how the API works. And it's kind of a busy user experience, and I'm not going to show you each and every option here, but I want to give you a quick sense of how this works. As an app developer, I basically say, what are the different types of launch that I want to test out right now in my app? Am I focused on an EHR launch, or am I focused on a standalone launch? And I'll show you an example of each of those. What version of FHIR am I working on? We don't yet have support for FHIR R4 built in, but that is coming soon. We're focused right now on R2 because that's what's widely supported in production from real-world EHRs. And so I'll be showing FHIR DSTU2 in these examples. And then there are some details that we'll talk through a little bit once they become relevant. But if I want to show, for example, an EHR launch, I've got a link in the slide deck to a very simple tutorial app. Anybody can follow this link from the deck and try the same thing from your own PC. So I'm going to show you an example of code. This is using a tool called glitch.com, which is basically a web browser-based editor where you can put together some HTML and JavaScript files, and they will host them for you. And anybody can take this and basically fork this project. Glitch calls that remixing. So you can take this and tweak it and try out some different capabilities inside of the app. So in this case, if I want to show you how an EHR launch works, I've got an app here that defines what's called a launch page. In this case, it's ehr.html. And based on that launch page, we can use the Smart on FHIR JavaScript client library. So we're loading that script here. And the launch page basically says, OK, if I'm being launched, I need to dig into this authorize process. So I'm going to call FHIR.OAuth2.authorize, pass along my client ID. And we'll talk about where that comes from. And I'll pass along a set of scopes, which are the permissions that I need. So in this case, I'll be showing you an app that's going to make a plot based on some basic patient demographics and on hemoglobin A1C observations. So we'll be using the observation resource. And I'll show you how I can use that Smart App Launcher tool together with this example app that's running on Glitch. So I've got a few links here inside the slide deck. My EHR launch page is being hosted here. And I'm going to click on the link, and you're going to see that it's broken. If I just try to follow this link, basically nothing happened. It's just going to say loading with no further information. Because this EHR.html page is not designed to be navigated to directly. It's specifically designed to be called as part of an EHR launch flow. So if I show you back in our app launcher, there's a form at the bottom that says, what is your app launch URL? And this is a way to simulate launching the app inside the EHR. So I'll paste in that web page that I just showed you, and I'll click the Launch App button. And now what happens is I've got this sort of simulated EHR frame that is taking up the top of the screen and the left-hand side of the screen. And in this case, the app itself will run inside of this inline frame, or an iframe. And here it's grabbing a set of historical hemoglobin A1C values and just doing a quick plot of them. And that's what the app looks like if you launch it using the EHR launch. Similarly, we can also launch it using a standalone launch. So there's a second link that we've got here to the standalone.html page. It's one more entry point in the example app. And in this case, navigating there kicks off a connection right away to our Sandbox environment, where it's going to display this question here. Do you want to authorize the app to access your data? I'll say, yes, I do. And then it'll direct me back to the app. And it's doing the same kind of basic plotting exercise. I won't go through the code of the app itself, but I do want to highlight that it's designed to be pretty simple and readable. Basically, all the activity that's happening in this example app is built into the main index.html page here. There's a function that gets the A1C data. It goes through all the FHIR observations and sorts them by date. And then it calls a library called Plotly, which it uses to make that graph. So it's really about 50 lines of JavaScript that goes through the process. It uses the Smart on FHIR client library to make that happen. And that's the basics of how this example works. I want to show you one more feature of the launcher so you can start to get a sense of what all those sort of configuration knobs and dials can do. So for example, when we do a standalone launch, you can configure a bunch of details like which patients to use by default, or you can simulate errors, which can be very helpful for testing conditions that might be hard to come across in real life. So I can tell the app launcher, what I want to do right now when I'm testing my app is I want to simulate the error that would come with an invalid redirect URI. So I'll say, great, please simulate this error for me. And what the launcher gives me is a FHIR server URL that I can use in my standalone app that'll, in this case, simulate the error that I requested. So I can go back to my standalone launch page and update my FHIR URL that I'm connecting to. I'll just paste in the new one that I got a moment ago from the launcher. And now, if I run this standalone page again, I'm hoping to get an error. Aha, an error occurred connecting to the EHR, because that was the error that I asked the launcher to simulate. And if I go back to my standalone page, if I undo that and connect to the previous URL, then in this case, I have to go back one page. Then in this case, reloading it takes me, well, all right, live demo. I won't go through the details of fixing that right now. I think I just have to hit the save button. OK, so that's an example of how you can use the launcher to configure correct behaviors, but also incorrect behaviors. You can test out your app in the EHR launch, as well as in the standalone launch. Overall, question.
Do you have to use JavaScript, or can you use Angular?
So the question is, do you have to use JavaScript? And actually, it's a good segue. So we have a set of libraries that we provide that help you build apps in a variety of languages. You don't have to use any of these libraries. You can always start from scratch and build your own client library in your language of choice. But the Smart Health IT project provides a JavaScript library out of the box that can be used with some JavaScript frameworks like Angular or like React, as well as just in a generic JavaScript app. I should say the JavaScript client library that we have is kind of old in the tooth, long in the tooth. It's getting old. We're working on a version 2 of that library. And all this lives at the GitHub Smart on FHIR organization in the client JS repository. And so all the code that you'll see right now in client.js is for the version 2 library, which is under active development. We're hoping to have this published by the end of the month. But this version 2 in particular will be much easier to slot into frameworks like Angular or React. It doesn't make as many assumptions about the environment in which it's running. So there's a variety of languages in which we provide support. You don't have to use any of this support. All you need to do to build an app is make sure you're following along with the open specifications. We also have a set of open source sample apps, also from that same GitHub organization, including the growth chart app that I showed you a demo of a little while ago, including the pediatric blood pressure app that I mentioned that we deployed at Boston Children's Hospital, and some simpler apps that are really just designed to show you, from the developer's perspective, how do you connect and make the kinds of data queries that you need to get started. Finally, I want to say a few things about sandboxes for testing these apps. I showed you an example of the Smart Sandbox that was linked to from our app launcher. And that sandbox environment comes with a set of de-identified data, as well as a larger set of synthetic data that you can try out from your app. The synthetic data comes from the Cynthia tool. But there are many commercial vendors and other projects that are hosting sandbox environments as well. So notably, if you go to open.epic.com or code.cerner.com or to the Allscripts developer site, you can try out their sandbox environments and build an app once and see what it takes to connect it to each one of those, as well as to the Smart Sandbox. Graham Grieve personally maintains a health intersection FHIR server, which is the reference server for the FHIR spec overall. It includes the Smart on FHIR functionality. And HSPC, the Healthcare Services Platform Consortium, also has a really nice sandbox environment where you can go and create your own dedicated sandbox, which will maintain resources that you want to have in there over time. So if you're thinking about doing sort of longitudinal demos, it's a great place to go and get kind of infrastructure set up. So there's many places that you can go. My general recommendation is that the easiest place to get started, like day one, when you've got an app running on localhost on your laptop and you want to just try some things out, day one, go to the Smart App Launcher, connect, tweak some of the parameters, and see what happens. That's a great initial step. But then connecting to some of the commercial EHR sandboxes is a great place to get a sense of what works out of the box in terms of interoperability and where are there different expectations. Where are there API endpoints where Epic expects one set of parameters and Cerner expects a different set of parameters, because there still are some rough edges like that. We try to do what we can to document those and to smooth over them in some of the client libraries. But that's probably the best way to get started appreciating sort of what those differences look like in the real world. I mentioned in the Smart Sandbox itself, we have one sort of longitudinal set of data that comes from de-identified real-world patients, and then a much broader set of Cynthia data, as well as some patient-reported outcomes that we translated into FHIR from some of the NHS pre- and post-surgical surveys. I won't go through the details of it, but there's a link here in the slides to the data browser, which allows you to go quickly sort of through the set of sample patients that we have in the Smart Sandbox and identify patients that might be a good fit for some of your demo apps, or to demo some of your apps. What we found is that most clinical applications have some subpopulation on which they're most relevant. And so from the developer's perspective, it's great to pick 1 or 2 or 3 sample patients that are going to be the best ones to demonstrate your own app. So you can use this tool to find those patients and then pre-program them in so you can filter down the list of patients to just the ones that are going to make sense in the context of what you've built. Links to the launcher. I wanted to include links to a tutorial that was written by the team at Cerner, but allows you to get started running a smart app that can connect to any compliant server. And again, I've got a glitch.com site with that tutorial preloaded on it if people want to try that out of the box. So those are the basic resources that I wanted to show you. We've got maybe just a minute or 2 left if there's questions at the end. Otherwise, I'll be around for the whole conference and really happy to connect offline. Yeah, please.
With regard to the public sandboxes from some of the EHR vendors, do you see any breakdown in validating differences of versions, say, different versions of Epic between different providers in real world scenarios versus those public sandboxes?
Yeah, so the question is, for public sandboxes, like, for example, open.epic, they have one implementation of the Epic server, but then in real life, there's hundreds of Epic providers that are running that software, sometimes on-prem. And are there differences, are there gaps, are the behavior sometimes divergent? The short answer is there's a common core of the software stack in that case that's running at every one of those sites. But things like which mapping tables have been created can be provider specific. So the quality of coded data might be different from site to site, for example. It's still pretty early days. We've been doing in the Sync for Science project some small scale work to be able to compare the consistency of that implementation across a variety of sites. And so far, we've been pretty pleased with what we've seen. I can also say just anecdotally from my own perspective, I've got a GitHub repository called jmandel/myhealthdata, where I've got data from 2 Epic systems. And if you want to just sort of browse around and see what the data look like, I've just posted that all publicly. There's not a lot there, but there's at least enough to get started, getting a sense of what's changed from site to site. We've got time for one more question. Yeah, please.
Do you think any value in taking SMART and applying it beyond FHIR to maybe something like OMOP or like the Vivo ontology to pull into not just from clinical but towards researchers as well?
Yeah, so SMART, as I described it here, really provides an authorization workflow and a way to give permissions and share context. Can this be deployed or applied beyond FHIR? I think the short answer is yes. There's been some work already to ask for domains that aren't commonly stored in the EHR, for things like imaging data that researchers might want to get access to. How can we use this set of tools without having to sort of reinvent the world? And so the advanced OAuth session that I do later this week on Wednesday will cover a little bit about that. But even beyond FHIR altogether, yeah, I think it is actually a very good starting point if you're thinking about building a set of user-facing permission screens on top of many kinds of clinical or health-grade data sets. With that, I will wrap up. I think it's time for lunch. Thanks, everyone, for your attention.